To graph a trig function, we first need to write it in the basic form, which has b factored. Here b is 2. We have to take 2 out of the brackets and write what's left over after we divide both those inner terms by 2 before we can actually see what the phase shift, amplitude, and period are. Now I'm going to give you lots of graphs so you can do this in steps. And the first step is we want to graph all the expansions without the translations. So I'm just going to graph y equals 3 cosine of 2x. So the 3 tells me the height of the wave. That's the amplitude. The 2 tells me that I'm compressing the graph 2 times horizontally. This tells me that 2 waves fit from 0 to 2 pi. Okay, and on this graph, here's 0, here's 2 pi. So in that space, I want 2 basic cosines. I know cosine starts at the top and ends at the top, and I want to fit 2 of those waves from 0 to 2 pi. So I know the height of the wave is 3. So I know I'm going to start at 3, and I also know I'm going to end at the top, so I'm going to end at 3. So now it's all about filling in what's left over. So what I can do is I can break this up into 2 halves. I've got 2 waves that I want to fit. So halfway, I'm going to have to get back up to the top again. Now I know that in between 2 maxima, halfway between 2 maxima is the minimum point. Okay, so I know I've got 6 boxes here. So if I break that up in half, I'll get to 3 boxes on each side. So the middle point between the maxima is going to be 3 boxes across, and it has to go down to -3 because my height of the wave is 3. I can do the same thing on this side. I go from my max to max, and halfway between those 2 maxes, I put my minimum point at -3. Now halfway between a max and a min is a middle point. So now I know that halfway between a max and a min, I have to cross the x-axis. So I have 3 boxes across, so halfway will just be 1.5 boxes. 1.5 boxes between a max and a min, it'll go through the middle. And it's important that you fill in this whole graph, not just on the right-hand side, but for all the values on the graph, both positive and negative. So to do that, you can repeat the pattern. To get from one max to the next, I go 1, 2, 3, 4, 5, 6 boxes, and I get to a max. 1, 2, 3, 4, 5, 6 boxes, I get to a max. Same thing. The distance between minimums is also 6 boxes. 1, 2, 3, 4, 5, 6, minimum. 1, 2, 3, 4, 5, 6, minimum. And then if I go 1.5 boxes halfway between the maxes and the mins, I obviously can't count properly because that point went too far. Here it is. 1, 2, 3, 4, 5, 6. That's right. And there's all my points. They're all separated by the same amount so that the shape of the graph doesn't change on the left side compared to the right side. I just can copy paste one wave and I get all the rest. So that is my expansions. So now I'm going to put in the translations. So I've got my basic graph, I've got the amplitude correct, and I have the period correct. Now I'm going to take that graph and I'm going to move it pi over 3 to the right and up 1. So the positive 1 at the end means up 1, and the C value is the phase shift, pi over 3. So because I have 12 boxes to get from 0 to 2 pi, I know that each one of these boxes is pi over 6. So I have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and finally pi. So if I want to go pi over 3 to the right, I just need to go 2 boxes to the right. That's 2 pi over 6's gives me pi over 3. So now I'm going to take this top point right here, and I'm going to move it 2 boxes over and 1 box up to put it over here. And I'm going to do the same thing with every single point. I'm going to move it 2 boxes over, 1 box up, and put the results on the graph below. Oops. But I also know that the shape is going to stay the same. On the top graph, I skipped 6 boxes to get to the next max. So the same thing happens here. 1, 2, 3, 4, 5, 6 is the next max. So now I'm going to cheat and go 1, 2, 3, 4, 5, 6 backwards and put the next maximum without having to move every single point. Yeah, I can do this for the bottom points, moving them over 2, up 1 to get to this point here. But then I can kind of cheat and remember that if I skip 6 boxes, I get to the next minimum. So I just skip 6, get to the next minimum. They're halfway between the maxes. Okay, and now the middle of the graph is this dotted line that I'm drawing. You don't actually have to draw it as a dotted line, but that's where those 1.5 points are going to be. They aren't going to be on the x-axis anymore. We're going to take them, and they're kind of hard to move. We're going to move them over 2 and up 1. So they're still going to be at halfway points. But they're going to be kind of in the middle here. So 1.5 boxes between the maximum and the minimum will give me the middle. So that's what's nice about sine and cosine. Everything spreads out so nice and evenly. Okay, so make sure that you fill up your whole space on your graph. Connect it, make sure it doesn't look like triangles like that one. Sometimes I find that to graph this, it helps to just draw a whole bunch of mountains. And then just turn your paper upside down. And do the same thing on the other side. A whole bunch of mountains. That turns into a really nice looking sine graph. So I really don't recommend doing this with a graphing calculator only, but it's a great way to check your answer. So if I go to my graph and I plug in the original problem, I'm not going to plug in what I did to factor out the b, because what if I made a mistake with factoring b? I want to make sure, even if I factor b or don't factor b, the graph looks the same. I want to make sure that this is correct. Okay, so what I do is I choose Zoom Trig, because that gives me the same window that I have here almost. I might want to change my window so that the y values go from -5 to 5, so that it's exactly the same as what I have pictured here. There it is. Okay, so I'm going to count the number of maxes. I've got 1, 2, 3, 4. And here I've got 1, 2, 3, 4 maxes. I've got 1, 2, 3, 4 minimums. And I've got 4 minimums on my graph. And this crosses at just below 0, 0, which I can see is true on my graph as well. So this confirms that I graphed it correctly. So now I want to define the amplitude, period, and phase shift. So going back to my graph, which was 3 cosine 2 x minus pi over 3 plus 1. The amplitude is the absolute value of A. It's always positive. So that will be 3. The period has a formula. Period is 2 pi over b. So here b is 2. So 2 pi divided by 2 gives me a period of pi. And the phase shift is my c value. So the phase shift is pi over 3. I can't see that until I factor out the b. If I have a negative sign in here, then my phase shift is positive. Positive means the graph moves to the right. But if I had something like x plus pi over 6, then the phase shift would be negative because the graph is moving to the left. So just in case this comes up, it's kind of opposite of what you see in the brackets here. Positive turns to a negative for the phase shift because we want left to be a negative phase shift and right to be a positive phase shift.